Job interview, software developer, the live code refactoring. Characters: Marcus, senior staff engineer, observant and inquisitive. He wants to see how the candidate thinks through technical debt. Maya, full stack developer, analytical and vocal. She excels at explaining the why behind her coding decisions.
All right, Maya. For this part of the interview, I've shared a link to a code sandbox with you. Do you see it?
Yes, I have it open. It looks like a legacy function for processing user orders.
Exactly. This is a real snippet from an old service. It works, but it's a mess. How would you start analyzing this?
First, I'm looking at the function length. It's about 150 lines long, which is a red flag for a single unit of logic.
I agree. It's doing way too much. What else jumps out at you immediately?
There are a lot of nested if-else statements. It's a classic arrow code shape, which makes it very hard to follow.
How would you address that nesting problem first?
I'd use guard clauses. Instead of nesting the entire logic inside a check, I'd return early if the data is invalid.
Go ahead and refactor that first part. Talk me through it.
Sure. I'm changing if, order, null, dog, to if, order, null, return. This flattens the structure immediately.
Much better. Now look at lines 20 through 45. That's the pricing logic.
I see it. It's calculating discounts based on user type, item category, and holiday dates all in one place.
It's pretty brittle. If we add a new discount type, this function gets even longer. What's your solution?
I would extract this into a separate discount service or use a strategy pattern.
Why the strategy pattern in this specific case?
Because it allows us to define different discount algorithms and swap them out without changing the core order logic.
That makes sense. Now, look at how the database is being queried inside that for loop.
Oh, I see it now. Line 55 is making a database call for every single item in the order array.
What's the technical term for that issue?
That's the n+1 query problem. It's a major performance killer as the order size grows.
How would you optimize that to be more efficient?
I'd pull the database call out of the loop and use a where-in clause to fetch all necessary item data in one go.
Good call. Now let's talk about variable naming. What do you think of data1, list2, and temp?
They are terrible. They don't convey any intent. I'm renaming data1 to validated order right now.
Naming is often the hardest part of software engineering, isn't it?
It really is. But clear names act as documentation for the next developer who reads this.
Speaking of documentation, there are no comments here. Would you add any?
Only if the logic is inherently complex. I prefer code that is self-documenting through clear structure and naming.
I like that philosophy. Now I see a hard-coded API key on line 102. What's your take on that?
That's a huge security risk. We should never commit secrets to version control.
Where should it go instead?
It should be pulled from an environment variable or a secure secret management system like Vault.
Correct. Now what about error handling? Currently, it just prints the stack trace.
That's not great for production. We need a global error handler and structured logging.
What kind of information should we include in those logs?
We need a correlation ID, the timestamp, the user ID, and a clear error message without exposing sensitive data.
Excellent. Maya, you've mentioned dry principles before. Does this code violate dry?
Yes, lines 80 and 120 are almost identical calculations for sales tax. I should move that to a helper utility.
Let's talk about testing. If you refactor this, how do you know you haven't broken anything?
I wouldn't touch a line of code until I wrote unit tests for the current behavior, even if that behavior is messy.
So you create a safety net first. What testing framework do you usually use?
I'm very comfortable with just for JavaScript or Junit if we're working in Java.
How do you handle testing that external API call on line 110?
I would use a mock to simulate the API response so the tests remain fast and deterministic.
Great. One last thing. This function is currently synchronous. Should it be asynchronous?
Definitely. Since it involves I/O operations like database calls and API requests, It should be an async function.
Why is that important in a Node.js environment, for example?
To prevent blocking the event loop, we want the server to handle other requests while waiting for the I/O to finish.
You clearly have a deep understanding of both clean code and system performance, Maya.
Thank you, Marcus. I believe refactoring is an essential part of keeping a codebase healthy over time.
I couldn't agree more. Let's move on to the next section of the interview.
See you in the next English conversation session by Wisdom Studio 8.